Hello again folks. Tonight's video is going to be a project build, but I'm going to start off by saying it's a fairly niche project build that will appeal to, I suppose, quite a small cross-section of YouTube viewers. The project I'm going to be building tonight is a Commodore Amiga joystick tester. Now, for those of you that don't know, the Commodore Amiga was an extremely popular home computer back in the late 80s, early 90s, and it's still got a massive following today. I myself own several Amigas, I think 6 at the last count, and I do quite often come across old accessories and stuff like that at car boot sales and on eBay and that. And sometimes, I should mention I don't have the space at home to have my Amiga set up all the time, nor would I want to with a couple of young kids running around. But yeah, sometimes I just wish they had the facility to test the joystick, without having to set up the computer. So that's what I'm going to build tonight. It's going to be a really simple project. The majority of the time building this will be in the cutting of holes in the enclosure and stuff like that. But we'll sort of gloss over that. I'll show you me starting that process. I'll pause the video, finish it off, and show you the end result. So without further ado, let's have a look at the components. So very, very simple. The Amigas use a 9-pin D connector. So of course we're going to need a 9-pin D socket. Here's one here, solder bucket type, ideal for this application. We're going to need an enclosure, and I'm going to use this small one here. Now this is made by Serpac. It's a 231AL, and it's a nice little enclosure. It can take a 9-volt PP3 battery, and of course it comes with the screws. Nice 2-part case enclosure, well, whatever you want to call it, and it's going to be an ideal size for this project. And I intentionally purchased this colour because it matches the Amiga. That's off-white, beigey plastic, if you want to call it, stuff that pretty much all vintage computers came in. These are ABS, so I think they're ABS, that is. So there should be no risk of this yellowing like the Amigas sadly do. Of course, we're going to need a 9-volt battery connector, because of course we've got 9-volt battery compartment, so we need a connector for said 9-volt battery. I did have a nice RS Components one, but unfortunately when it's fitted to the battery it's too wide to fit in the battery compartment, so I'm just going to use this El Cheapo one from China. A couple of bits of wire, a couple of bits of heat shrink, and some LEDs. Now these LEDs are pre-set up to operate at 9 volts, which is absolutely fantastic for this project because I'm using 9-volt battery. However, if you're going to build this yourself and use a 9-volt battery with sort of standard off-the-shelf LEDs, you may need to, or you will need to, consider fitting a resistor in series with the LED to limit the current. These, like I say, these come pre-set up. There is a resistor pre-soldered inside these LED modules, if you want to call it. So I don't have to include any resistors in the circuit, which is quite nice. So just something to consider. These are really, really nice LED, what do you call them, bezel? No, it's not bezel, clip, whatever you want to call it. The machined aluminium with of course the nut and the washer on there, and they're just a really, really high quality item. I got a job lot of these on eBay quite a while ago, extremely, extremely cheap. And I'll be honest, this is the first opportunity I've had to use them because they are set up for 9 volts. We don't tend to use 9 volts in projects these days. It's normally 5 or 3.3 or 12 volts, that kind of thing. But yeah, really nice. Anyway, Chris stopped on about LEDs. A couple of bits of heat shrink, and that's pretty much it. So, with all that said and done, the first thing we need to do is look at our enclosure and see how we're going to mount the LEDs and the socket. So I've had a little bit of a play around, as you would expect, before starting the video. And of course the big thing, or the big consideration, is this battery compartment. So having a look at the enclosure, we can see it is 8 centimeters across. So ideally, joystick, we think of a square pattern, forward, back, left, right. We want that, or I personally want that to, be kept in a sort of square within the enclosure. So looking here, let's say 8 centimeters that way, 8 centimeters this way, it's quite nice. It takes us up to the edge of the battery compartment, so that's going to be absolutely perfect. We've got to consider the socket as well. Now, there's probably well, there's not enough space to put it the battery compartment side, so it is going to have to go in here at the front. Now, if I show you the side aspect of this enclosure, you'll see that there is this angle. It's not a square edge, so if I put it down, at this side, it's going to be facing down towards the bench or whatever, and potentially could be putting strain on either the joystick connector or the the connection itself. So it is going to have to go on the top of the enclosure. And simply how I'm going to mount this is to cut out a hole. I'll mark it out, drill it out, and then file it out to make it nice snug fit. And I'm going to mount it from the back, sorry, from the inside, and put it out, and then screw it in using these two holes. So I think that's going to be quite a nice finish once it's done. There's no requirement of what do you call it? Not standoffs, but the little nuts to screw into, because all Amiga joysticks just plug in. So yeah, that's pretty much what we're going to do. We're going to mark it out in a square. We will take into consideration the length of this socket and the screws, and mark out a square, and put these LEDs in a sort of cross shape with a central one for the fire indication. The Commodore Amiga, I've never seen a Commodore Amiga joystick that has two fire buttons, although it is listed in the pinout. I'm content just to have one fire button. If I do come across a joystick that does have two fire buttons, then we can also obviously link the other connection into the same LED, and it'll be just fine. So, enough talking, let's get on. Now, I've run out of masking tape. I don't know where my masking tape is, so I'm just going to use some of this glass reinforced tape just to essentially mask off and allow us to draw on the enclosure without causing it any damage. So just cut that there, fold that end over so we can get it off easily. Now, I believe this is 4 centimeters wide, and I've just made a pig's ear of that. Let's take that off. Pop it on like so. And we'll just measure that to make sure it is 8 centimeters. So it's just under 8 centimeters. So I'll just adjust that very slightly. Check it at that. Yeah, that's close enough. Yeah, close enough. Okay, so now that we've got our essentially a square of tape, hopefully that's coming out in the camera. I'll just adjust that. Can you see that there? We're simply going to take a ruler and go from one corner to the other corner. Get it all nice and lined up. Put a small line that way and do exactly the same. And because it is a square, we know that is our centre point. What I'll do at the top here as well is I'll get this centralised, and I'll mark it the 4 centimeter mark that way, and do the same this side. And similarly this way as well. And what this is going to do is give us our centre point where we can make our cross on. Okay, so I'll do a vertical line here. It should go through the cross. Like so. And like so. So there we go. Hopefully that's quite clear on there. So clearly this is going to be our fire LED in the middle. I need to consider the screws and that. So I'm going to do, wait till we see. think we'll do 1.5 cm. Let's get two together and see how close they are. So that should be fine. Yeah, 1.5 cm looks good to me. Yeah. So I put 1.5 cm, we'll go 0 there and 3 there. Okay, so there we have it. Our case is nice marked out, ready for drilling. And what we'll do now is I'll stop the video and basically drill those out, and I'll come back to you once it's all ready. So if you bear with me, I'll catch you in a moment. Okay, right, I've just drilled those out using my little step drill. Not too bad, fairly symmetrical, maybe slightly too low on this one, but yeah, it looks alright. And as you can see on the top here, I've just marked a centre line, put a little centre line on the connector itself, popped it up against there, drew around it, and what I'll do now is I'll pop the video on pause, I'll drill that out and file it out, and then we'll come back once that's done. So bear with me yet again. Okay, right, that's the aperture cut out for the connector. It's not perfect, but it'll do the job. And if we just pop the connector in there like so, you can see that it's a relatively nice fit. It's not, let's say it's not perfect, but it'll do the job. So, yeah, I'll get some isopropyl alcohol and just take off that permanent pen. Give us a nice clean enclosure to work with. And similarly, we'll just take that off the connector there. One last thing we need to do, actually, thinking about it, is we need to mark the holes for the, what do you call it, mark the holes for the, well, for the holes. Yeah, mark where we're going to drill the holes, is what I'm trying to say. So we'll get that as square as we can. And just go like that. Yeah, that's good enough, I think. Okay, right, yeah, I'll start the video again. I'll drill that out, and I think what I'll do is I'll screw the LEDs in as well, just to get us started, and then we'll take a look at the circuit diagram and then wire it up. So again, bear with me. Okay, welcome back. Right, that is the holes poorly drilled. I've come up with a solution for that. I'm just going to put some washers on just to cover up the mess. And as you can see, I have installed the LEDs and it looks fairly symmetrical. Quite pleased with that. Excuse me. So, next thing we're going to do is start soldering it up. Now, on these LEDs, as always, well, not as always, but generally, if you're buying LEDs from China, you might want to check, but the longer lead is 99 times out of 100 the anode. So what I want to do is join those all together, because that is how the circuit is designed. Here is basically the connector. Here, as you can see, the back of the connector. I've got ground here, so the 9-volt negative supply is going to ground on pin 8. The anodes are all common together and connected to the positive side of the 9 volts, and then we've got pin 6, which is a fire button, and 1, 2, 3 and 4, which is forward, back, left and right respectively. So yeah, I'm going to common all the anodes together and get that job out the road, and then it'll simply be a case of connecting the cathode for each LED to the relevant pin on the socket. So let's do that now. So I'm just going to bend all the anodes together, and I've anticipated that this probably isn't going to reach. You know, they're not all going to reach out, so I may have to join a couple with a small piece of wire. But I think the easiest thing to do for the actual cathodes is just to bend them to one side. Now, I had intended putting some heat shrink on this, but to be honest, I don't think it's really going to be necessary if we're very careful. So hopefully you can see this. There's all our anodes together on that side. Got 2 on this side, and I'll just solder those together. Some solder would help. And you can be fairly liberal with this. It's not going to cause you any great problems. Too much solder on here. And I have prepared Blue Peter style, one I prepared earlier, just a small piece of wire just to branch those two together. For those of you that are too young or not from the UK, Blue Peter is a children's TV programme, and they used to build things, and that was a famous catchphrase. Here's one I've prepared earlier. They would have something waiting on the side to bring in just to save them a bit of time. Probably teach you to suck eggs there, but never mind. Okay, right, so that is the anodes coming together. And all I'm going to do now is tin up these cathodes. And we'll apply some wires to them. There you go, hopefully you can see that through the smoke. Now I'm not going to go for any particular colour scheme for these. I'm just going to tack on a wire and then we'll work it out as we're going along. Alright, okay, so just make sure I've not got any shorts. I shouldn't have, because I've cut these leads to the correct length, so they should all be okay. Right, now let's get on to the socket. So let's get a Chris card out, totally stealing off Dave Jones there with Dave card, and we'll tin up these buckets on the back of the socket ready for the wires to go into. So we need one here, 2, 3 and 4, and then 6 and 8. So, right, I think not often I use this, but we'll bring in the helping hands here, might make it a little bit easier. And just to stop confusing myself, obviously we're looking at this back to front, so forward and back. In fact, I'll just write on there, forward, back, and of course this is going to be left and right. Another way we could have done that would be 1, 2, 3 and 4, and that just avoids any confusion when you're doing this. So pin 1 is forward, like so. Pin 2, which is this yellow, is back. Pin 3 is left. And pin 4 is right. So looking at that, they're not going to move around in shot. We'll turn it upside down. We'll take our fire, which is going to pin 6, which must be the end one here. And that's us. So last thing to do is attach a wire to, in fact we don't attach a wire to that, we use our battery connector, so I'll just tin that up. Hopefully you can see that. Now I've just pre-installed this, as you can see, So we've got enough space to get the battery out, connect it and then slot it in. I've put a little knot in there just for strain relief. So we'll turn these up. The positive is going to, where's the positive going to? Is going to the, positive on here, the anodes, and the negative is going to the ground connection. Right, there we have it. So what I'm going to do now is, I'm not going to stop the video. I'm going to do it, and we'll see if it works together. Okay, so just gently put this socket in, like so, and then what I'm going to do is just gently move this wiring around, pop it down into the enclosure, and just verify that there is no shorts. Now, like I say, you can use heat shrink if you want, but I don't think it's really necessary. So I've got some screws here and some nuts. Unfortunately, I didn't have any M3s shorter than this, so we'll just have to use them. I'm going to put some shake-proof washers on, or serrated washers. Of course, they're not shake-proof, they're shake-resistant. There's no such thing as a shake-proof washer. Okay, there's one on. Hey, nearly there. There's the washer. Right, I'll get a screwdriver out. So these are T10s, so I'm going to use my little weeder set. Yeah, thanks very much. I see a couple of you actually purchased a couple of sets. 3 of you, I think, have purchased these screwdrivers through my links on my last video. So yeah, thanks very much for that. Very kind of you. So that little bit of a commission will go towards, you know, purchasing kits and other bits to show you on this channel. So yeah, thank you very much. So we'll get this adjusted up so that it looks as nice as it can do. So now I'm just going to hold these nuts with a pair of needle nose pliers. And tighten that like so. And let's do the other side. Like so, nice and tight. Right, one final check that everything's looking good. There's nothing shorting. And we'll gently pop the two halves together. Like so. Get my screws out. This is confidence, putting it together without testing it. Although, in reality, there's nothing really can go wrong with this circuit, really. It is fairly straightforward. What are we doing for time? 25 minutes. Well, I was hoping to get this sub 20 minutes, so apologies for that. Last screw. Let's get everything out of the way. Fit our battery. I struggled to find a 9-volt battery, then I realised I took that one out of the little 830 multimeter that I blew up the other night. So yeah, it lives on for a short while anyway. Okay, right, that's our little unit complete. Socket on the back, obviously, to plug the joystick in, which we'll do now. Like so, and let's test it. So, forward, back, left, Right. Fire. Happy days. Yeah, really simple build, although it took 25 minutes to do it. Yeah, for not a lot of money, you get a nice little, you know, semi-professional little unit you can use to test your retro computer stuff. Of course, if I didn't mention at the beginning of the video, if you're not into Amigas and you're maybe into Atari or you know, what other Amstrads or whatever, you could always use a different type of socket for those types of computers if they don't use a 9-pin D, that is. And just check the pinout. You can get pinout diagrams quite easily on Google Images. So there we go. Hopefully you found that quite interesting, useful possibly. And yeah, thanks very much for watching. If you enjoyed the video, as always, give me a thumbs up. If you didn't, give me a thumbs down. And if you haven't already done so and you'd like to do so, please click on my fat head just about here and subscribe. Thank you very much for watching. Take care of yourselves, and as always, all the best.